Oh, warm welcome all of you. My name is Rakesh Rao, working as Assistant Professor in Department of Mechanical Engineering, Maharaj Institute of Technology, Mysore. Today I will be handling a session on mechanical power transmission, which is a part of Module 4 as per your curriculum syllabus. Let us see what exactly is the transmission. Transmission is nothing but we are transferring something. So mechanical power transmission is nothing but we are transforming mechanical power from one place to other place. If we transfer mechanical power from one place to other place, this is called as transmission systems or drives. Generally what happens here in transmission systems, there is one rotary shaft. Shaft is nothing but it is a round rod. Again in other place there is another one more shaft. Say we can say it is a parallel shaft. When we want to transfer a rotary motion from this shaft to that shaft, we need to have a power transmission system or a drive. So here transmission systems are nothing but the systems which will transfer mechanical power from one place to other place. Let us see some of the examples of transmission systems. They are, number one, they are nothing but belt drives, next rope drives, chain drives and gear drives. These are the four devices based on speed and power of transmission system. Other transmission systems are also there based on distance between them. So let us take in detail what are the belt drives as per your syllabus. In your syllabus they have mentioned belt drives, gear drives. Let us see what is a belt drive. A belt drive, the name itself indicates belt is used for driving the transmission system. That's why the name belt drive. So belt can be anything. It can be a leather belt, it can be a rubber belt, it can be a fabric mixture of canvas and cotton, it can be even balata. These are the different materials we will be choosing for belt. Balata is nothing but it is a mixture of balata gum and acid along with some waterproofing agents. Basically balata gum, from that we derived balata fabric material. So balata usually it is called as cow tree or bullet wood. Let us see in detail what is belt drive. The power is transmitted from one place to another place between two parallel shafts. In such cases we are using belt drive. Let us see the classification of belt drives. The belt drives are classified based on the speed and based on the type of belt. Let's see what are the different classification based on the speed. So number one, light drives. The name indicates light. It is having light power, low power. So we will be measuring speed in terms of 10 meter per second. If it is up to 10 meter per second, then it is a light drives. Example for that is any agricultural machining. So you can take any agricultural machines like sawing, gardening tools. Those are nothing but examples for light drives. They are very light. Then medium drives, the power is medium. So velocity is 22 meter per second. Machine tools are the examples for medium drives. Then heavy drives, large power applications greater than 22 meter per second. It can be even 60, 100. Those are classified under heavy duty or heavy drives. Example for that is compressors, generators, etc. Then let us see one more classification of belt drives based on type of belt. If the type of belt used is flat, then it is a flat belt drive. Flat belt drives are used when the distance between driver and driven is within 8 meter. The name driver means which drive the wheel, driven means which drivens the wheel. This is a driver wheel, this is a driven wheel. This will be rotating like this. So the type of belt used here is flat belt drive. So the distance is within 8 meter. Then V belt drives are used. The type of belt is V whenever the distance between driver and driven is within 2 meter. Short range of span V belts are used, and V belts are suitable for low and moderate power application, but flat belt drives are used for moderate power application. Next, circular belt or rope drive. The type of belt is circular or a rope. The cross section area is circular and it is used for high power application. The distance between driver and driven will be greater than 8 meters in case of circular or flat belt drive, circular or rope drive. So these are the typical examples of belt drives. Let us see the types of flat belt drive. So we are taking flat belt in detail in this module. That's why we are concentrating on type of flat belt drives. Remember, whenever we use belt drives, you have to know this: power is to be transmitted from one place to another place between two parallel shafts. This condition should be there. And flat belt drive is the distance between driver and driven is within 8 meters. So both the conditions must be satisfied whenever you want to select a flat belt drive. And these flat belt drives are moderate power application. Again, moderate is nothing but medium power application. You can choose the velocity 22 meter per second. Let us see the different types of flat belt drives. In that, open and cross belt drive. Open belt drives are the belt drives when the direction of rotation of driver and driven are same. So here driver rotates in clockwise, driven also rotates in clockwise. The direction of rotation of driver and driven are same, then it is called as open belt drive. If the direction of rotation of driver and driven are opposite, then it is called as cross belt drive. So here driver is rotating in clockwise direction, but driven is rotating in counterclockwise direction. Even this case is also possible. If the driver is rotating in anti-clockwise direction, driven can rotate in clockwise direction. That is also possible. That's why directly we mentioned direction of rotation of driver and driven are opposite. Then cross belt drives are used. There are some terminology here. This is a driver wheel which drives the wheel. This is a driven wheel which driven the wheel. And we are using a shaft. Shaft is nothing but it is a round circular object. The wheel is rotating in the clockwise direction. Here the driven wheel is rotating in again clockwise direction. The direction of rotation are same. So these two are the drives. Belt we are connected for these wheels in order to transmit power from one place to other place. One more thing, important thing, this is a tension side, we will call it as the tension of the belt is more here. So that is maximum tension side is nothing but tension side. Minimum tension side is nothing but slack side. These two terminology will be using for derivation. Next, cross belt drives. The rotation of driver and driven are opposite. Again, tension side, this is slack side. You need to know this type of arrangement when we take up the length of belt drives derivation. These are the belt material as I explained: leather, rubber, fabric, balata. These are the different belt materials chosen depending upon the application of the particular thing. Even you can compromise with cost. That is also possible here. Let us see some of the important terminologies in belt drives. Number one, velocity ratio. Velocity ratio is very important while choosing the belt drive. Velocity ratio is nothing but it is the speed of driver to the speed of driven. Total velocity in the belt is same. So velocity of driver will be equal to velocity of driven. So this is a condition when we choose any belt drive. Velocity of driver, the notation for driver is 1, notation for driven is 2. So whenever we take velocity, it is pi d1 n1, because it is with respect to driver, one terminology will be using. For driven, 2. So it is pi into d2 into n2. Velocity is nothing but pi into d into n. Got it? Usually velocity will be in meter per second. So let us calculate these two. Pi will get cancels. So n1 by n2 will be equal to d2 by d1. So they are inversely proportional to each other. So this is the velocity ratio. n1 by n2 is nothing but velocity ratio which is given by d2 by d1. So this term will be d2 by d1. If thickness of belt is considered, then it will be d2 plus t divided by d1 plus t, where t is thickness of belt. Even you can write n2 by n1, that is also possible, but velocity ratio should be speed of driver to the speed of driven. That compulsory you have to use. Next, second condition is slip. Slip is nothing but the name itself indicates it slips. So basically what happens? The belt will be giving a frictional grip. So here in the mechanical, friction is advantage in case of belt drives. Sliding of belt causes relative motion between belt and pulleys. That condition is called as slip. There is a movement and that movement is decreases the velocity ratio. That is disadvantage there. So in order to have that condition, when this movement occurs is whenever the difference in tensions exceeds mu r. So we can say frictional resistance. Whenever it goes to friction, it exceeds mu r, then this condition will occur. So difference in tensions is nothing but delta T. Delta T is nothing but T1 minus T2. T1 is tension in tension side, T2 is tension on slack side. So this T1 minus T2 is delta T. So the condition of slip is equal to delta T is equal to mu into R. Whenever we take a friction into consideration, frictional force is proportional to normal reaction. This frictional force is equal to mu into Rn, where this mu is nothing but coefficient of friction. Coefficient of friction, this is very important. Coefficient of friction is between two members. Say for example, I am standing on the ground. If I am standing on the ground means it should have some friction. Because of friction I am standing. Otherwise I would have just sliding here. So friction is advantage here. The same function of friction will be done in case of belt drives. So instead of this F, this is delta T. We will be taking forces in terms of tension, differences in tension. Tension side and slack side, T1 minus T2. So mu into Rn. When tension in forces exceeds this mu into Rn, then what happens? Sliding will be taking place. This sliding we don't want, because of which the speed can be increased or decreased, we lose our velocity. That's why this slip condition we need to avoid. So the equation for slip is d2 divided by d1 into 1 minus s by 100. Here slip is measured in terms of percentage, that's why s by 100 is considered. This is an equation to calculate velocity ratio when you consider a slip. Then another important is creep in belt. Creep is another one of the mechanical property terminology we will be using, but creep is here during rotation of driver and driven, there is an expansion on tension side, contraction on slack side. Expansion and contraction is taking place on tension and slack side, due to which relative motion of belt over the pulleys will occur. This condition is nothing but creep. Sometimes we need to avoid this. So this is a formula to calculate velocity ratio using the creep. Velocity ratio is nothing but n1 by n2 speed of driver by speed of driven, d2 by d1 we have seen here, then e plus sigma 1 with root e plus square root of sigma 2, where sigma 1 and sigma 2 is nothing but stress. Stress is nothing but resistance offered under the loading. So when it is a stress, we will call it as force by area. It is a mathematical term. Internal force offered for the specimen under loading, that is nothing but stress. Again one term is there, strain, ratio of change in length by original length. And when we correlate these two are related with a Hooke's law. Stress is directly proportional to strain. This is a Hooke's law under elastic limit. When we take proportionality constant outside, we will get E. So E is nothing but sigma by epsilon. So sigma is nothing but stress, epsilon is nothing but strain, E is nothing but Young's modulus. So here we are using Young's modulus of the material. Young's modulus of the material is constant. If you take a steel, it is 210 gigapascal, that is constant. So material of the belt, Young's modulus depends upon material of the belt. So material of the belt is constant. So that's why E is constant in both driver and driven. Sigma 1 and sigma 2 will be changing. Stress will be inducing in tension is different rather than slack. That's why we are using sigma 1 and sigma 2. So this is the creep when we considered in the belt. Next, another important is initial tension. This is very important, initial tension in the belt drives. When we want to move the vehicle in a static condition, it is very difficult. We need to overcome the friction. So there is a friction we need to overcome. After that we can ride easily. Here, in case of initial tension, the motion transmitted by the belt and pulleys by firm frictional grip. There is a frictional grip. We need to increase the firm frictional grip even when it is rotation. It should not become loose. Belt should not come out from the pulleys. So that's why we need to establish a firm frictional grip, and we need to increase it even when it is under rotation. So to increase the grip, what we will do is, the belt is mounted on a pulley with some tension. When you want to put a new belt into a mills, what happens? So initially it is very tight. We need to elongate the belt and we need to put it. So that is one of the conditions. That elongation we need to elongate. That is nothing but initial tension they will be giving. Because of initial tension, the belt will sit on either of the wheels with greater frictional grip. That will enhance more grip during the rotation. So that is nothing but initial tension. So tension on tight side, tension on slack side. Tension on tight side means T1 minus T0 initial tension. Slack side T0 plus T2. So if you take this, we will get T0 is the initial tension, T1 is tension in tight side, T2 is tension in slack side. So this is the equation we get for initial tension in belt drive. So this derivation is not there, but this equation sometimes they will ask in definition. Let us see finally the power transmitted in belt drives. The power transmitted, as you know, it is nothing but torque into omega t, torque into rotational direction. So here we are taking linear motion, linear velocity into a consideration. That's why we multiply with forces. Forces is nothing but here it is tension. So this is in Newton, tension is in Newton, velocity in meter per second. So Newton meter is nothing but joule, joule per second is watt. This is a unit of power. When you want to convert this to a kilowatt, divided by 1000 you can do. This is a power transmitted in belt drives. There are some of the disadvantages of belt drives. So the disadvantages of flat belt drives is they are not suitable for smaller distances. It reduces angle of contact. Reducing the angle of contact is one of the major here. That's why this is one of the disadvantage here. And exact velocity ratio cannot be maintained. In each cycle, we cannot maintain exact velocity ratio. That is very difficult because there is some friction here that will be changing. Even that causes slip. Slip will also change velocity ratio. And slip and creep causes loss of power. That is one of the negative here. Then high power cannot be transmitted effectively. If you want to transfer for high power, flat drives cannot be used. In such cases, V-belts are used. V-belts are widely used in high power applications. The shape of V-belt is trapezoidal in nature. It is one of the trapezoidal, and because of this, firm frictional grip will be there. V-grooves are provided, and wedging action of the belt and V-grooves enables them to transmit at high torques. Because of that V-grooves, it will increase the grip, so that will transmit the power at higher torques. The power transmitted by the V-drives can be operated with several belts, multiple powers we can use, and we can transmit power from 0.5 kilowatts up to 150 kilowatts. That is one of the advantage here. Advantages of V-belt over flat drives are they can transmit high power. V-belts can transmit high power. V-belt can be used for smaller distance. V-belt permit large velocity ratio. That is also important, speed ratio or velocity ratio. There is no slipping of belt compared to flat drives. V-drives has less slipping. Then it is possible to continue the drive temporarily if one of the belts snaps. That is one of the advantage in case of V-belt drive, and we can operate with the shaft at any position, and several machines can be driven from a single driving shaft. These are the several advantages of V-belt drives. The next important topic in the belt drives is derivation of length of open belt drives. So here we will be concentrating on flat belt drives. First let us see what are the derivation here. Derivation of length we will be considering. So length of open belt drive. Very important derivation. This will be asked in the examination. Either they can ask open belt drive or cross belt drive. So this will be asked for 10 marks, and also this is very important for the problem solving. Let us consider open belt drive. Let us recall the definition of open belt drive. Open belt drive is one whenever the rotation of driver and driven is same. That is nothing but open belt drive. I will be writing the open belt drive. First I will be considering the driver wheel. Driver wheel will be bigger. Then this is having a center O1. O1 be the center of this, and this will be a radius, so I will call it as R1, and D1 be the diameter of this. This is diameter D1, and this is radius R1 at any point. Then I will continue the same thing. Then I will write a driven. This is a driven wheel. Usually driver wheel will be bigger and driven wheel will be smaller. As you know, the velocity ratio, velocity of driver and driven will be equal. So velocity of driver is pi1 d1 n1, velocity of driven is pi2 d2 n2. So total velocity will be constant. To satisfy this, one wheel will be bigger, one wheel will be smaller. Then this is center O2, and the radius will be R2, and the center distance will be, center distance of these two wheels will be calling it as X. Then what I will be doing is, I will connect these two wheels with the help of a belt drive. So I will be connecting these two with the help of a belt drive. So this point I will call it as E, where the belt leaves driver pulley. This point I will call it as F, where belt enters driven pulley. This point I will call it as G. This point I will call it as H, where again belt leaves driver pulley. This point where belt enters driver pulley. So these are the important points we will be considering it. Then what I will do is, I will join these points. I will join these 2 points with the center. Again I will join these 2 points to the center. And also another most important thing is, this angle I will be calculating. This angle is nothing but angle of driven pulley alpha. Again this is alpha. This is alpha. Again this is alpha. Just to understand the line, construction line, I will draw a line at center O2 parallel to EF. So this is a line I will be drawing. This point is called as M, and this angle is called as alpha. Then I have to consider the length of the open belt drive. Look here, very important thing. First I will consider this length arc. First I will be considering the arc length. This is arc length. Arc length is this one. I will make it dark. G. This point I will call it as J. I will call it as J. H. This point we will call it as K. So this is arc length. Then after that, EF, this length, it is a belt length. Then again I have to consider this driven pulley arc length. Then again this length. So total length is nothing but, I will denote it by L. This is nothing but arc length of, or arc of GJE plus EF plus EF, then arc of FKH, this arc, plus HG or GH. This is a total length of a belt drive, open belt drive. Then very important thing is, whenever you start this, the direction of rotation should be same. The direction of rotation should be same. This wheel is rotating in clockwise direction. This wheel is also rotating in clockwise direction. Very important. First you have to start with directions. People will forget this always. First you have to start with directions, then these are the length. So arc of GJE is nothing but, just I will show you arc of GJE. So arc of GJE is nothing but G into J plus J into E. G into J plus J into G. But here GJ is equal to JE. That's why what we can directly write, GJ plus GJ, this is equal to 2 into GJ. Similarly, we can write it for EF. This EF is equal to GH. So EF is equal to GH. Then again arc of FKH. Arc of FKH is nothing but, directly I will write FK plus KH. So 2 into FK. Similarly, I will write this. I will take 2 common. 2 into GJ plus EF plus FK. So this is the total length. So 2 GJ. What is GJ? This is G into J. That is nothing but length of the arc. Length of the arc is nothing but S. Usually we would be using in mathematics, radius into theta. This is the formula whenever we calculate length of the arc. Similarly here also, this length we need to calculate. This length is nothing but radius R1 into theta. Theta is nothing but, I have to take angle here to here. So this is nothing but pi by 2, 90 degree plus alpha. So 90 degree plus alpha is nothing but the angle across this length GJ. Pi by 2 plus alpha 1 plus EF. EF, I will be deriving it later, plus then arc of FKH. Again FK plus KH, 2 into FK. FK is nothing but this angle. So total angle is 90 degree. 90 degree minus alpha. So radius is R2. S is equal to R theta. So S is equal to R into radius. Theta is angle pi by 2 minus alpha. That is 90 degree minus alpha. Then let us calculate EF. What is EF? Let us see. So EF is equal to, this EF is equal to O2M. O2M. I will be considering a triangle O1, O2, M. So consider triangle O1, O2, M. In this triangle, this is 90 degree line. Opposite is alpha angle. So I can use hypotenuse theorem. For hypotenuse theorem is hypotenuse side square is equal to adjacent side square plus opposite side square. Opposite is O2M square. Here I have to calculate O2M. So O2M square is equal to O1 O2 square minus O1M square. So let us see what is O1 O2. O1 O2 is nothing but x square minus O1M. So I will take this O1M is nothing but, I will consider this line segment O1M. So O1M is nothing but O1E minus ME. O1E minus ME. This is the O1E line segment. We will be considering O1M. Let us see what is O1M. O1M is equal to O1E This is O1E. O1E is nothing but radius of this R1 minus ME. ME is nothing but this portion. I will be bringing this portion here. ME is nothing but O2F. O2F is nothing but radius 2. R2. I will be considering O1M R1 minus R2 whole square. Got it? Next, let us see O2M. O2M is nothing but square root of x square minus R1 minus R2 whole square. So I will be taking x as a common, x square into 1 minus R1 by R2. So here nothing is there. If I take x common, so x will sit on here. So this is divided by x square. Since square is there on both sides, I will be considering like this. Along with a root, I will bring a root here. This root will get cancels. X into square root of 1 minus R1 minus R2 by x whole square. So we have to simplify this. This is O2M using binomial theorem. O2M will be equal to x into 1 minus, this will reduce, R1 minus R2 whole square divided by x square. I will be splitting the powers into factorial 2, that is nothing but 2, plus it goes on, since it is power up to 2, we will be considering it x multiply with this bracket x minus x into R1 minus R2 whole square divided by 2 into x square. 1x will get cancels. This is x minus R1 minus R2 whole square divided by 2x. This is O2M. Why we calculated O2M? Because EF is equal to O2M. So this is equal to EF, and I will substitute the value of EF in this equation. 2 into R1 pi by 2 plus alpha 1 plus EF x minus R1 minus R2 whole square divided by 2x plus R2 into pi by 2 minus alpha. So what I will do is 2 I will take outside, it is as it is. Pi by 2 is here, this pi by 2 and this pi by 2 I will take common. So pi by 2 into R1 plus R2. So this is also plus pi by 2 into R1 plus pi by 2 into R2. Then plus alpha, this is not alpha 1, this is just alpha. If I take alpha common, alpha into R1 minus R2. So that is the next equation, R1 minus R2 plus x minus R1 minus R2 whole square divided by 2x. So this is a equation, and one more thing here we have to do is, what is alpha? I will consider triangle. Here you have to consider triangle O1 O2 M. I will consider sine alpha. This is sine alpha. Sine alpha is nothing but opposite side, that is OM, opposite side by hypotenuse, that is O1M. This is the opposite side divided by hypotenuse, O1 O2. So what is O1M here? O1M is nothing but, again this we have derived here. O1M is nothing but R1 minus R2. O1 O2. O1 O2 is nothing but this distance, center distance x. So So for small angles, sin alpha tends to alpha. That is, for a smaller angle, sin theta tends to theta. Same limits we are using. So alpha is equal to r1 minus r2 by x. So this is the equation for alpha. Here there is a alpha. You have to consider this very carefully because this alpha will be changing in cross filter. Here it is different, whereas in cross filter it is different. So consider this alpha. I will multiply with 2. Then what happens? Pi into r1 plus r2 plus, what is alpha? Alpha is nothing but r1 minus r2 by x. So r1 minus r2 into r1 minus r2 is r1 minus r2 whole square divided by x plus x minus r1 minus r2 by r2 whole square divided by 2x. Then this is the length of belt rail. This will not completed. Again I have to write the same equation here. Pi into r1 plus r2. If I take r1 minus r2 by whole square into x, this is the length of open belt rail. This is not over. I have to do one more step here. So what I will be doing is, I will retain this pi into r1 plus r2 plus, from here and here I will be taking r1 minus r2 whole square by x common. If I take that common, what happens? This is 1 minus 1 by 2. 1 minus 1 by 2 is 1 minus half. So 1 minus half is 1 by 2. So directly I will write 2x plus x. So this is length of open belt rail. Remember these two. If I take r1 minus r2 whole square common, so r1 minus r2, r1 minus r2 whole square by x common, it will be 1 minus 1 by 2. 1 minus 1 by 2 is 1 by 2 into r1 minus r2 whole square by x. So this will be equal to r1 minus r2 whole square divided by 2x. This is the equation for length of open belt rail, where it depends upon r1 plus r2, radius of driver, radius of driven, then alpha. Alpha is nothing but r1 minus r2 by x, then x is nothing but center distance of the wheel. This is how open belt rail is derived. Very important you have to remember is sin alpha here. Sin alpha is equal to r1 minus r2 by x. Sometimes what happens, they will give angles. So they will give angles for larger pulley. Larger pulley is nothing but this one, driver pulley. This is driven pulley. So if I consider larger pulley, what is the angle of contact here? Angle of contact is 90 plus alpha. So sometimes this is also given, but I have to calculate total angle. What is the total angle here? This is a total angle 180 degree plus 2 alpha. 180 degree plus 2 alpha. This is the angle of contact for larger pulley. Similarly, angle of contact for smaller pulley or driven pulley is this. Here it is total angle is 180 degree. 180 degree minus alpha. So 180 degree minus 2 alpha. This part is also changed in open belt drives. So this is very important, you have to observe. And also this sin alpha is equal to r1 minus r2 by x.